welcome to one of the most exciting and powerful concept in Java, inheritance. In our previous session, we have learned about how encapsulation and how to protect our data. Today, we are going to learn about how to build families of classes. Inheritance is the secret to write less code while achieving more functionalities. It is the core of how we model the real world in software. Let's get started. So, what is inheritance? In simple terms, it's the mechanism where one class gets or acquires the properties and behaviors of another class. Think of it like a parent and a child. A child inherits the physical traits like eye color or height from their parents. They might also inherit property or a house. In the same way, in Java, a child class inherits the properties like variables and methods from its parents. You don't have to write the same code from scratch. You simply inherit it and add your own unique features on top. The primary goal here is reusability. If I have a class that already works perfectly, why should I want to copy and paste the code into my new class? I shouldn't. I should inherit it. We use two main terms here, the superclass. This is the parent, it's the source of the features. Second, the subclass. This is the child, it's the one receiving the features. Remember the easy relationship. If you can say a car is a vehicle, then inheritance is appropriate. If you can't say that, you probably shouldn't be using inheritance. Let's look at how we actually write this in Java. We use a very specific keyword, extends. Look at the code on the left of the screen. Class subclass extends superclass. This one keyword, extends, tells Java to create a link between the two. A quick note, the subclass inherits all the public and protected members. However, private members are strictly private to the parent and are not inherited directly. This is where encapsulation and inheritance meet. Java supports three main types of inheritance with classes single, one parent, one child, simple and clean. Multi-level, a grandparent relationship. Class C extends B and B extends A. Hierarchical, one parent but multiple different children, like a father having three sons. Now pay attention here because this is a favorite interview question. Does Java support multiple inheritance? The answer is no. When using classes, Java does not allow one class to extend two parents at the same time, like A and B both giving birth to C. This is to avoid the diamond problem where the computer gets confused about which parent's method to use. We solve this using interface, which we will cover later. When you are in a child class, sometimes you need to call your parent. For that, we use the super keyword. Think of super as a direct phone line to the parent. You use super.variable if the child and the parent have the same variable name, but you want the parent's version. You use super.method to call the parent's version of action. And most importantly, super method calls the parent's constructor. This must always be the first line in the child's constructor. Next is the concept called method overriding. Imagine the parent class has a method called sound. For a generic animal, the sound should just print sound. But for a dog, we want the sound to be bark. Overriding allows child to provide a specific version of the method that is already present in the parent. The name and the parameters must be same. This is how we achieve runtime polymorphism. This is the common point of confusion for beginners. What happens to the constructor during inheritance? The rule is simple. The parent is born before the child. When you create an object of the subclass, Java automatically calls the parent's constructor first and then the child's constructor. If you have a class B extending A and you say new B, the output will be AB, never BA. The base must be built before the extension, which means first the parent class, that is A, will be executed, then B. Why do we love inheritance? Because it saves times, reduces errors, and makes our code easier to maintain. You fix a bug in the parent, and it automatically fixes in all 100 children. That is efficiency. However, there is a catch: tight coupling. If you change the parent structure drastically, you might accidentally break all the children. This is why we must design our hierarchy very carefully. You must know the difference between overloading and overriding. Overloading happens in the same class and uses different parameters. Overriding happens between parent and the child and uses the exact same parameters. Think of overloading as one person doing many things, and overriding as the child doing it differently than the parent. To wrap up, inheritance is about building on top of existing success. Thank you for watching the video. Catch you guys in my next video.